Well, hi there, boys and girls. I'd like to start this video out with a shout out to Sandra and Katie from 6th period who were walking around helping people with the shortcut on how to add and subtract fractions. And I wanted to show this to you, but it was really nice to see. Katie went around about 3 different tables and helped people with this, and it's really helpful for me. That's the way I want the class to go anyway. You know, ask other people when it needs to be a group effort for some of this, because I can't get around to everybody. So anyway, Sandra and Katie, I'm proud of you for that, and again, it's very helpful. So here's what they were showing people. If you want to add 2 fractions together, of course, we know we have to have common denominators, but instead of doing common denominators, you can crisscross multiply. You can take 5 times 1 and then 2 times 3 and add those together, and then the denominator is 2 times 5. So this is 11/10. You can do this in your head. This also works for rational expressions in subtraction. And with this, you do bottom right times top left. That goes first. And then this is minus. And then sine times sine is sine squared. And then on the bottom, you've got sine times cosine. So this is a quicker way of adding or subtracting fractions, not having to mess with common denominators. Anyway, off we go. We're going to be practicing proofs now, and before you do this, I've got this student notes under assignments right here. This is some helpful things you might want to write down or print this off. Just some helpful things if you don't know how to start one of these proofs. So I've got this under assignments under Edline. But off we go. Whenever you prove an identity, you simply start with one side. You must pick with one side. You cannot work with both sides. And you typically want to start with the side that looks the most complicated, the one with all this stuff, because math is all about simplification. And if you start with something that's complicated, it's easy to simplify. So obviously that would be this side on the left here. So I'm going to start with this side, and I'm going to work with that side until I make it into a 1. First thing I'm going to do is I notice that I have a common factor of secant squared in both of these terms. So you can factor that out, secant squared x, and that leaves me with 1 minus sine squared x. Now, because of a Pythagorean identity, cosine squared x plus sine squared x equals 1. This is probably our most important Pythagorean identity. Almost everything, all of our identities are derived from this. If you were to subtract sine squared from both sides of this equation, you would get that cosine squared x is equal to 1 minus sine squared x. Get used to that. That is a very common substitution. Very common. So if you see 1 minus sine squared, go ahead and call it cosine squared. And of course, we know that these are reciprocals of each other. Secant squared is 1 over cosine squared, and then times cosine squared over 1, and we have exactly what we wanted. We can cancel as long as we're multiplying, and so we get 1. Yay! Next example. Now here I've got 2 sides, both seem complicated, and there's not always one correct way to start this, but I'm going to start with the right hand side because there's bigger powers there. And I want you to remember some difference of squares things from Algebra 2, and that is that a squared minus b squared factors into a plus b times a minus b. And also a to the 4th minus b to the 4th would factor into a squared plus b squared times a squared minus b squared. So remember your difference of squares, please. I'm going to use that here. I'm going to start with the right hand side, and I'm going to have secant squared x plus tangent squared x times secant squared x minus tangent squared x. Now, we also are going to use a Pythagorean identity here. You should know from your formula chart that tangent squared x plus 1 is equal to secant squared x. Get used to these Pythagorean identities because we're going to use them a lot. Now, what happens if we subtract tangent squared from both sides? We're going to get that 1 is equal to secant squared x minus tangent squared x. You will get used to this, and you'll start to notice that you'll use this more often. So once you do it 2 or 3 times, you'll be like, hey, I've seen that movie. I know how this goes. So if you see secant squared minus tangent squared, you can just call it 1. Okay, now we want to keep our eye on the prize here. Over here is what we're trying to prove. We're trying to prove this is equal to 1 plus 2 tangent squared x, which means I'd love to substitute for secant squared x, and well, I have it right here still. Secant squared x is equal to tangent squared x plus 1. And since I have like terms, this is 1 plus 2 tangent squared of x. So I've proved it. Yay. Chaw. Alright, so let's go on to the next example here. The left-hand side is the most complicated side, and I'm just going to use a simple substitution here for cosecant. We know that cosecant x is equal to 1 over sine x. So this is 1 over sine x times cosine squared x over 1 plus sine x over 1. And that simplifies to cosine squared x over sine x plus sine x over 1. Of course, we talked about this. You multiply fractions. It's the top times the top and the bottom times the bottom. Now we're going to use this little shortcut about adding 2 fractions. We're going to crisscross multiply. So that's going to be cosine squared x plus sine squared x over sine x. And again, we did that times that times that for the numerators, and we added them, and then that times that for the denominators. Now you really have to get used to this. Every time you see cosine squared x plus sine squared x, that's going to equal 1. That is so important to remember. And now we're to 1 over sine x, which we know is the very definition of cosecant x, which is what we're trying to prove. So this is equal to cosecant x, which is exactly what we wanted. Check. Alright, this next example here, I've got a little screen shade because I wanted you to be able to write down my reasons. I'm not sure if you write down the words that I say that you hear, so I want you to write down these reasons because this is going to happen a lot. If you have a fraction and there's 2 terms in the denominator, I want you to have this here. So whenever a single term has 2 terms in the denominator, multiplying by the conjugate of the denominator usually does the trick. Now the conjugate means you're going to multiply the top and bottom by this denominator, but you're going to change the sign. So I'm going to tell you what the conjugate is. The conjugate, you might have done this with square roots in Algebra 2. The conjugate of 1 plus cosine x is 1 minus cosine x. I'm going to show you what happens and why this is so cool. What you're going to do is you're going to multiply the top and bottom by 1 minus cosine x. That's just a clever form of 1. This is 1. You can multiply anything times 1. It's the multiplicative identity, and you're not going to change anything. So we scroll this down, and this is what I'm doing. So you're not going to distribute the top, but you are going to FOIL the bottom. If you FOIL the bottom out, you get 1 minus cosine squared. You see a plus b times a minus b? That is just equals a squared minus b squared. That's a difference of squares. But I don't want you to distribute through the top. Now, what does 1 minus cosine squared equal because of Pythagorean identity? Well, it's equal to sine squared. And then, since you're multiplying, you can cancel one of those signs, and now you have a minus b over c. And I want you to know this, that a minus b over c equals a over c minus b over c. You should have that in Mr. G's pet peeves at the beginning of the year, when at the very front. This is a true statement. Now, if you flip it over, it's not true, but this is a true statement. So you're going to separate this into 2 fractions, 1 over sine minus cosine over sine, which is exactly where we're trying to go. 1 over sine is cosecant, cosine over sine is cotangent. And that's what we have. Okay, last example. Sine over cosecant plus cosine over secant. Now, you might be able to crisscross multiply and do some stuff here, but watch how neat this is. Cosecant is the reciprocal of sine. See, this is like sine of x over 1 over sine of x. So the cosecant x becomes a sine x on the top, so you can just bring cosecant to the top and it becomes sine. Or you can flip this over and multiply. dividing by fractions, you flip it over and multiply. So we get sine x times sine x, and the same thing happens here. Secant is the reciprocal of cosine, and so that's cosine x times cosine x. And what do we have here? We have our basic, most important, Pythagorean identity. Sine squared plus cosine squared, and that equals 1. Boom, shakalaka. I will see you guys tomorrow.